I appreciate you stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about the QuantAsylum QA40x series of audio analyzers. There is a QA401, a QA402, of which this one is, and a QA403, and I believe the very first one may have been a QA400. This one is the QA402, as I mentioned, and it has been replaced with the QA403, which basically does everything but has a bit better THD and SNR capability. So I thought I would show how I measure different things as far as with the software and how I set up my loads and connections. If you were just given this thing, they do have a lot of wikis on how to set it up, but I thought I would kind of show a modern recent example with the software that I have. Plus, I'll be honest, the owner of the company, who is probably their chief engineer, really sharp guy, we'll just call him Matt, he watches the channel and said, hey, I would like to send you a new QA403. Is that okay? yeah, that's fine. That's fine. I would love to do that. He didn't say anything about me doing any reviews. He just said, keep doing your reviews on vintage gear. I love them. But I thought as a service to the community, the QA40x community is really, really good, and Matt's a big part of it, and there's a lot of sharp people in there. Anyway, if you have about $600, these run about 600 bucks, it is without a doubt the best investment I can think for anybody that wants to do any kind of audio work. I mean, you could spend 30-some thousand on the audio precision stuff, which does a lot more, but for what I do, and probably what a lot of people or small businesses do, this thing is much simpler to use than a lot of the sound cards, and there's some other devices, but this works really good. And once you get kind of the hang and feel of it, I would put it under my pillow if I could, but I really love it. So anyway, most of the stuff I'm going to show you is with me off camera, which is probably good, and I'll kind of just go through some of the basic loads and things that you need, and then I'll go into measuring an amplifier and show you how I set stuff up. There has been several of you that have asked for a video on how to do measurements. I do know that there's a few other channels probably that do show that kind of thing, but I thought I would specifically show it for, you know, the most recent version of the software and kind of some things I've learned about measuring gear. And in this case, we're just going to start with the power amplifier and see how that one goes, and then maybe we'll do something else. So anyway, just hope you enjoy it, and I look forward to your comments at the end, and I will have links for some of the items. I'm not set up with any kind of Amazon referral program. There'll just be some pictures of the stuff that I found that worked well, and you can obviously find them elsewhere. So anyway, I hope you enjoy this and look forward to hearing your comments. This is what the QA403 audio analyzer looks like, and pretty much I think it's identical to the QA402. The first thing we need to talk about is how to connect to it, and it does have BNC jacks. All of my testing is done using unbalanced RCA inputs and outputs, so I don't do anything with the output minuses for either the left or right. Those are just left open. They don't need to be terminated. They can be just left open. If you were to do balanced measurements, you would have to make your own adapter. Maybe you can buy them that go from BNC to XLR, but I don't do that. So the left and right output pluses are the ones that I use, and I use a BNC to RCA adapter. I'll show you those in just a moment. And over on the input side, now if I'm doing a preamplifier, the left minus and the right minus inputs are terminated into 50 ohm loads. I often refer to those as shorts because they're basically a short for audio stuff, but I'm going to show you what I use. They're just BNC loads, and they're just BNC 50 ohm loads. Now, the plus and the left plus and the left right, I'm going to use a BNC to RCA adapter. The cables that I am going to connect with on either the outputs or the inputs are going to be RCA cables. So you can buy a pair of a normal stereo pair of cables, or I usually buy the ones that are single cables, maybe 4 foot long, and they're good quality, just RCA cables. Usually they're like a subwoofer cable. Amazon used to sell a nice basic cable, but they stopped doing that, a single cable. So you're going to need 4 cables. 4 foot lengths it works pretty good for most everything I do, and they're going to have RCA on both ends. One thing we need to check before we get too far into trying to measure something, and this is brought out in the owner's literature for the QA40231 analyzers, and that is that if you are powering this from your computer or laptop, it may not have enough current capability, in which case you'll get an orange indicator around the USB voltage, and it tells you it's low. Also, you can see that it's drawing about 0.8 of an amp current. So what I have done is I have a USB powered hub, and I'll show you which that is. I got it off Amazon. It works really, really good. And the nice thing is you can switch your outputs on and off, which is kind of cool. And I like having the QA 402 or 403 analyzer plugged into that port, and when I'm ready to use it, I just hit the power on button. It also has a fast charge USB port as well. As far as I can tell, it doesn't really add any negatives to the noise level of the QA40x analyzer. And it's a good idea to get one if you start getting this warning. Also, I'm going to show you the USB cable I got. Now, maybe a normal USB cable will work. I think the one I got was supposedly a little bit heavier duty, designed for a little bit more current, but you certainly could start off with a normal USB cable and see if it makes any difference. It's USB 2. One other thing I'm going to recommend that you purchase is this BNC female jack to RCA male plug adapter, and what you will do is connect the BNC 50 ohm load to the BNC end of this adapter, and then the other end you would plug into, say, your auxiliary 1 input or auxiliary 2 input on a preamplifier or integrated amplifier, or your line in if you're measuring a regular power amplifier. And assuming that it's stereo, you would use 2 of these, and that's going to terminate your input into basically a short. The 50 ohm load acts as a short, and so it makes it a lot better when you're doing a noise level measurement. Since we're going to cover testing an amplifier in this video, I thought at this point I should show you the load that I built. Now, there's going to be a schematic showing how things are connected, but basically the input starts over here at this end, and these 4 resistors, this one, this one, this one, and this one, they are 1 ohm 100 watt resistors, and they're all in series, and then they come over here. Now, these guys here are all 0.5 ohm 100 watt resistors. So if you do the math, I can get about 700 watts into either 4 or 8 ohms. This is a pretty hefty heat sink. You can't really tell on the side, but I don't know where I got these, but they're a lot of aluminum with heat sink fins on it. And I have put 700 watts into this load. Now, the input comes in here, and there is a tap here. So this is a 2.5 dB down tap at 8 ohms, and you'll see where that is in the schematic. Then there is another tap right here that I can use if I want to be 12 dB down at 4 ohms or 18.1 dB down at 8 ohms. I can use this tap. And what happens is this connector right here, this guy would be come out of this banana jack, and I'll show you what those banana jacks are that I use for this. So this is it's an insertable banana jack, I guess you would call it, and this lead right here, you'll see where that mounts schematically, and that For normal use, if I'm doing, say, less than 100 watts into 8 ohms, I can just use it as is. When I want to tap it off for a higher power level that I'm going to measure, because note the QA40X has a maximum voltage of around 32 volts. So what I figure is if I'm going to do about 100 watt measurement, I'm good using no taps. But once I get over that, just for safety, I'll start using at least the 2.5 dB tap for 8 ohms. And if I'm going to be putting out probably over 200 watts into 8 ohms or 4 ohms, then I'll go over to this tap over here. You would take this banana jack out and plug it into either here or into over there. The ground lead that QA40X minus input, either the left or right, this is for just one channel, that is right here. And then we have a few other things going on here where I got everything connected, and I'll show you schematically what that looks like. Also, this guy right here, the green terminal, if I take this right here, this banana jack, or both banana jacks, and plug it into here, that's for 4 ohms, and that actually starts getting measured down here. So that's kind of the way that I do things with my loads. This guy right here isn't really used. It's just kind of there for an old design that I had. So I'll show you the other ends of these and explain more where they go to. So this is a little bit different view showing where some of the connections are, and you can kind of get an idea of the heat sinks here. And this is kind of how things are wired. Here is a little bit different view, once again, showing the cables and the connectors that I use. And we have jacks right here. These are banana jacks, and they would go to your amplifier output, your speaker, where your speaker jack's on your amplifier. And I used 12 gauge wire for all of these cables. So they're just 12 gauge speaker wire. Hopefully you'll get oxygen-free copper wire. That seems to work great. Now these two guys are BNC connectors, and I'll show you what it is that I got from Amazon. And you are able to solder a 12 gauge wire to the center conductor of these. I do not connect the grounds on any of these BNCs, only the center conductor. So this guy goes to the QA40X left plus input in this case, and this guy right here goes to the QA40X left minus input. And you would do the same for the right side. It's the same setup for the right side. I just showed the one load, and we'll get into electrically how these are configured, where this cable goes, and kind of how these others fit into the load itself. Here is the schematic for what's going on with my load and the taps. And let me start off by saying that these first 4 resistors are 1 ohm 100 watt resistors, and then these next 6 resistors are 100 watt half ohm resistors. And I have them mounted to the heatsink using heatsink grease just to conduct better to that heatsink. With this load and these values, I have been able to put 700 watts into either 4 or 8 ohms without any problems. Now, if you leave it there for a minute or so, it does get warm. So the easiest place to start off with is the minus side, which is right here. And that comes right off this last resistor here. And basically, this is going to go to both your QA40X left or right minus input. This is that BNC jack, and you saw which ones I got off of Amazon. I'm sure there's others, but this seems to work. It is a little difficult mounting a 12 gauge wire to the center conductor, but I have been able to do that successfully so far. And once again, do not attach anything to the shield section of that cable. It's just the center conductor. And the other end of this cable is going to go to your minus on the amplifier, and this is a banana jack that you saw earlier on the cable. Now over here we have our plus input, and one end is going to go to your QA40X left or right plus input, and that also is the BNC jack, and then the other end is going to go to the amplifier plus, and that also is the banana jack that you saw in the previous picture. Now, if I want to do a tap into one of these other points here, I'm going to use this wire right here. Now, this comes off the plus, and this is always connected to the left or right plus input on the QA40x input, and that will come off of the amplifier connection, and then it's going to tap into here. If I tap into this point, and you saw, if you look on the load, there is a BNC jack that you would just plug the BNC connector into. If I plug into this first one here, and I'm set up for 8 ohms, I'm going to be down 2.5 dB, and you can offset that in the software, and I will show you later on how to do that. Now, there was another BNC jack kind of next to the 8 ohm input, and if I connect both of these wires, so both of the speaker amp and the QA40x left to right plus input are connected together through the banana jack that has the capability of connecting two things together. So if I move both the banana jack and the QA40x left to right plus input to this point, and that was just the empty banana jack on that front area of the load. If I move it over to here, now I'm set up to do 4 ohms. If I take that center tap, the one that goes to the QA40x left to right plus input, if I take just that wire and I move it down here, then for 4 ohms I would be 12 dB down. So that just allows you to measure a lot of power. Now, if I was on the 8 ohm tap down here, and I went down to this point with this input lead, I'll call it. If I move the QA40x left to right plus input banana jack lead over to this point here, then I'm down 18.1 dB. And I'll show you once again how to do that in the software. But this is the configuration that I have been using for doing my loads, and it seems to work rather well. After I recorded the section you just watched describing the load schematic, I decided to update a little bit to hopefully make it a little bit clearer, and there were just some things that I thought needed to be done differently on it. I should point out that QuantAsylum sells the QA451 programmable 8 4-ohm load seen here. It looks like it may be on back order, but it allows for connection into the QA40x audio analyzers, and I believe it does up to 200 watts for a period of time, I believe it says. And so that is another option rather than making your own loads. Right now I have connected my QA403 to my PC, and it is connected to the PC via the powered USB hub that I showed you earlier. Also, the load is connected to the QA403 and to the power amp. The power amp that I'm using is an Aragon 8008, which will be the subject of its own video, or it may have already been shown as a video prior to when this thing comes out. So what we are looking at here is the initial display kind of thing that you get. I did have a preset for getting these things here, all these different specs that I want to display, and let me just kind of go into that just a little bit. You can change whether you want something to be displayed in watts or peak RMS, or maybe you want THD plus noise as a percent rather than a dB. And the other thing I usually display is the system averaging, the system FFT, and the system Gen 1 for a single tone. If I were doing a Expo chirp suite, I would be pressing the system Gen EX. And so you hit those, and then it's going to display them here. Now, right now I have my scale set to dBV, and I'm going to go right click on that, and you can see it brings up this menu. This point right here, this external gain, that is where I would put the tap information if I were using a tap on my load. So if I was at the 2.5 dB tap, I would enter in minus 2.5 dB here. And also the load impedance. So if I go to 4 ohm loads, I'm going to change this to 4 ohms. And let's go ahead and hit OK. The other thing, this X log is where you can set your frequency, and it's set for 20 hertz to 20 kilohertz. I usually use the hand window for the filters. Sometimes I use rectangular. I'll go between them, but for most of what I've been doing, I've found the hand window works the best, but you could play around and see what works best for you. When you first power on the QA40x software, it usually comes up to the attenuator state of 42, which is the highest attenuation state. And I don't know if it defaults to 96K, but 96K is what I use for the sample rate for darn near everything that I do. If I were to press run, it starts actually running the analyzer. We'll do that in a minute. And the idle keeps the analyzer in a steady state mode when you're not running. And that I will try to explain later. We have our FFT. We can change our FFT level here. And right now we're set for 128K. A lot of times 64K is good enough, but I'll just move it to 128K. The longer or the bigger the FFT, the longer it takes to do a sweep. The other thing is the averaging. Usually I put that at maybe 3, or I have it off. And then these things, it's over here, the display, it's going to show what the inputs are out at and your frequency, and then you can turn off each channel separately. This right here changes your Y minimum. So let's go ahead and hit run and get something on. And you can see our right channel has got some noise going on. It may need to warm up a little bit. We're putting out about 5 watts into 8 ohms for both channels. And we obviously have, the right channel has a lot more noise. You can tell right here, the SNR is about 63 for the right channel, and for the left channel, it's about 90. So that probably has to do with this particular amplifier that has a Class A mode. We'll see if the noise level gets lower, but for what we're trying to look at, this is fine. Now, if I go ahead and change this Y minimum, you can see how it moves the scale. I believe the most negative it would be down is minus 160 dBV, and you can change it, the level back up. This is adjusting the low level, and then if you want to change the max level over here, you can go ahead and hit max, and it'll give you more room up here, or you can bring it back there. Now, I normally only use the dBV for looking at noise levels or sometimes looking at different filters. And I'm going to go ahead and set it to dBr. So click on dBr. What it's going to do is it's going to put the peak, in this case at 1 kilohertz, over to 0 dBV. And then what I usually do is I raise that level up. So I would hit the Y max, oops, other direction, and change it so that the Y max is at the peak of the graph. So that's kind of how that works. Now, if I wanted to turn off the right channel, I would click right here. And if I wanted to turn off the left channel, I would click that one. And that comes in handy sometimes. So when you hit dBr, if you right click on that, you'll get a menu. Normally, when I'm doing THD SNR plots at 1 kilohertz, if I click this button, set 1 kilohertz level to 0 dBr, whatever is at 1 kilohertz, the peak signal at 1 kilohertz, it's going to call that 0 dBr. And then you could also, if it wasn't at 1 kilohertz, you could just tell it to set the display peak, whatever that is, to 0 dBV. And you could also have it track the left channel. So if the level of the channel changes, it will also change the dBr reference point. We also have an axis. This scales to different presets. So here, if I click this one, you would go from 0 dBV to 160 dBV. And if you're wanting, just go to plus or minus 1. If you're looking at the frequency response, this one would get you to plus or minus 1. So we have, you can set different measurements here that you want to measure. I usually don't use this. So if I right click on Gen 1, we get another pop-up menu, and it's set right now for 1 kilohertz. If I wanted to be at, say, 10 kilohertz, I get it to 10, and we'll just click that and see what happens. It should move it somewhere over here. So there it goes. It moved it over to there. And if I go overhead here, I can change the amplitude of this. So if I want it to be, say, -3, oops, that's pretty big. If I want that to be -15, we'll say -15.6, we can go ahead and hit OK. And so it should drop the level. And it will tell you what the level is over here. So this right here tells you we're at -15.6 dBV at 10 kilohertz, and this is the -15.6 dBV is equivalent to 165 millivolts. We also can change that. So I'm going to go ahead and change that back. Oops, the right channel just cleaned up all of a sudden. So I can set that back down to 1 kilohertz. And we'll put it at minus, I don't know, was it 11, -11. Now, the other thing we can do is we can change how much this little scale right here, this amplitude up and down, how much that changes each time I click it. And right now it's set for ½ dB. If you're doing higher power levels and you want the change very small, usually I set that to 0.1 dB. And if you were changing the frequency, you could change this step size to, 500 hertz or something like that. So that's kind of what's in there. We also have the ability, this muting here, you can have nothing muting, which is the case right now. If I wanted to turn the left channel off, I could hit mute left, and that mutes the left channel. I believe it either turns off the left channel oscillator or puts a big attenuant in there. I'm not sure how it's done, but let me just mute right, and then we should see this right channel be real low. So if I go over here and we hit if I turn the left off, you can see that the right channel is down really small at this point. And if I go ahead and hit the mute on, so it's back to Gen 1, and I just turn the mute off, hit mute none, and then the right channel will grow back to where it should be, and I can go ahead and turn the left channel on. So that's kind of what covers that. Now for other tests, they're over here, white noise. I really haven't used white noise. The multi-tone test is here, and when we get into that measurement, we'll go over that. And let's see, we do have some different weighting. Sometimes the specs will call A weighting, so if I click on that, it kind of puts a filter, a bandpass filter sort of around 1 kilohertz, and so it makes the signals further away from 1 kilohertz attenuated. But that can be selected on. And there's also C weighting, and you can define your own weighting that you would like. And there's also RIAA weighting for when you're looking at a phono stage. So I think that's kind of just the basic goings on here. Now what I'm going to do is I'm going to move this down to 18 dB. Usually you want this as small as possible to optimize either your SNR or your THD. So you could say we're around 97, 96 dB, and if I go to 24 dB of attenuation, it may change a little bit. So it made it a little worse, and but our THD improved. So it's like 0.02 or 0.0008, and if I go to 18, watch the SNRs are both right around 93, 94. So the SNR is improved, but the THD may have gotten just a little worse. So you kind of want to optimize this. Now, if I went to 12, that may be too much, and too much signal going into the QA403. And I'm going to go ahead and click that. And you can hear the clicking sound. That's the QA403. It's also showing this is overloaded here. And so you can just back it down to 18, and that seems to work rather good. And so that's kind of the basic settings that I use for doing the power amplifier. Now, I always start off, there's kind of a standard test. You want 5 watts into 4 or 8 ohm loads at 1 kilohertz, and that's kind of what I'm looking at here. So if I wanted to increase the amplitude a little bit, watch how much the power goes, and you can see the input level changing. So if I increase it a little bit, now I'm at minus 11.1, and our power went up. So that's just kind of how that works. I can back it back down. And if you don't want to do a step size, let's say I want to go to 10 watts, well, I'm at 5.04 watts, so I just need to increase this by 3 dB. So if I add 3 dB to that, I can come over here and add 3 dB, which would be minus 8.6, and hit OK. And my power should be somewhere close to 10 watts, but that's too much power for 18. So let's go over to 24 dB attenuation, and we are pretty darn close to 10 watts. So you can always start off at 42. I would recommend starting off at the highest level as you're playing with that. And the other thing to keep in mind is the RMS volts right here and right here for each channel. So the QA40x has a maximum level to the input. It says 32 dBV max, and I try never to get anywhere near that if I can. The 32 dBV translates to about 40 volts RMS AC. So I like to keep the RMS volts, not much over 30 volts RMS coming out of the amplifier before I'm going to use a tap. But if you start off here, then you can start lowering the attenuation to a point where the QA40x isn't turning on the relays like you just heard. So this is kind of what's going on with this. Let me just get rid of the right channel. If I left click on a peak, it will give me a frequency and amplitude marker, and then I could go over to this guy here, and that is number 2, and that's saying at 2 kilohertz it's about minus 91 dB down, where the fundamental was here at 1 kilohertz. And you could put it on another one over here. So this is our 60 hertz. If I left click on that, that's 60 hertz, and it's 111 dB down from our carrier there. So it kind of just lets you do markers. And what you can do then is to get rid of them, you can right click and delete all markers. So that's kind of a little bit how the markers are used. Now if I want, I could save this as a setting. I'm going to set the Gen 1 to 5 watts, so that was at about minus 11.6. And I'll save that. Let's make sure we're at about minus 11.6. So we should be at about 5 watts, and we are, into 8 ohms. And the other thing, we were able to have good results with 18 dB of attenuation. So the neat thing is, what you can do is save this as an instrument state. So you just hit File, Save Settings. I have one here already called Aragon 5 watt 8 ohm. So you could just call it what you want and then save it. I'll just resave it. But it allows you to save them, and then you can also load them. So if I want to go File, Load Settings, and then it'll bring up all the different tests that I might have for different things. So that's pretty cool. Now you also have some visualizers that are handy. And if I go ahead and click on the visualizers, the one that I use is the THD bar graph. So let me click on that. It always shows the left channel. You can turn on the right channel here. And you could give it a title. We'll say harmonics. And so here's our fundamental at 1 kilohertz. And then you can see that actually the second harmonics, the even harmonic, is higher than the odd harmonic. So that's typical for tube amps. This is not a tube amp, but it gives you a display, and you have that available. You also have some other visualizers here. You can look through them. I guess there's an oscilloscope. I haven't really used these, so I'm not going to get into them. You also have a help menu here for doing certain things. Now, if I just go ahead and stop, so I stop the program from running. Now, let me explain the idle thing. So if I click on idle, what it's going to do is it's going to put out a 5 watt 8 ohm signal. So it's CW. Normally, the QA40Xs send out like a chirp, and it's so they can process it with the FFT. I don't know how all the math works, but if you're testing something, you will hear it, or if you were looking with the scope hooked up to the output, you would see it going up and down. And if you go to idle mode, what it does is it disables all the displays, but it will keep, say, a 1 kilohertz minus 11.6 dBV signal going into the amplifier. So it kind of acts as a high quality oscillator source. So that's kind of what that does. We do have the ability to print. You can export data as frequency series, or usually I would do frequency series, and I believe that saves it as a CSV file. And you can import a wave file. I've never imported a time series, but the wave files have to be specific to some of the settings for the FFT and the sample rate. You also have all your automated tests here, and we'll go over some of those a little bit later on, but that's kind of what is available to you. You can file, and then you can save bitmap, and it will let you save the screen as a PNG or a JPEG or a bitmap. So you can save that, or you could do a screen copy if you want, just for like a picture of what you have here. I believe it's just this window. It's not the settings and all that. So that's kind of the basic test in a nutshell for measuring the THD SNR of this particular amplifier, which actually looks pretty good once it stabilized here. So now that we've made the THD SNR measurement for 5 watts into 8 ohms, in this case at 1 kilohertz, what I'm going to do is the frequency response measurement. And one thing you want to do is note the input signal level that you needed to get 5 watts into 8 ohms or 4 ohms, as the case may be. In this case, it's minus 11.6 dBV. And what I'm going to do is come down here and click on frequency response, and I'm going to get rid of all these guys. Now you could just click on them and close them, or I can right click on this and I can just say uncheck all and hit OK. So now they're all gone, but I want some stuff there, and normally what I want is system averages, system FFT, and system Gen X. I'm going to go ahead and OK, so those get displayed. Now I want this to be minus 11.6. Just it's really not going to make that much difference, but I like to just say that at least at 1 kilohertz it should be about 5 watts into 8 ohms, we'll say. And this was minus 11.6. So hit OK, and then we can go over here and run, and we don't see anything yet. Well, you can just see something here at the top. So if I go to plus or minus 1, you can see that now we have a frequency response of this and of this particular amplifier, and this looks really, really good. It's fantastic, to be honest, from stuff that I see. But what I can do is zoom in. So to zoom in on this area, let's say I want to just look at between half a dB and minus plus or minus half a dB, so I can kind of get a cursor there and drag it around this guy, and now it'll zoom in. So it's an expanded scale, and you can see that it looks pretty good. Now you could also hit this dBr if you wanted, and hit set the 1 kilohertz level to 0 dBr, and it will do that. It tells you both channels are active at that point. But if say the right and left channel reversed, and it was the left channel that was down here and not on 0, you could just run that and say hit left channel, track left channel, and then you could also tell it to set the 1 kilohertz level to 0 dBr, and then it would move it to so that the 1 kilohertz point of the left channel is at 0. Hopefully that's making sense, but this guy is really flat. I mean, it's 0.15 dB maybe. It's pretty darn flat, and actually there could be some calibration done on your cables that connect to and from the QA40x. I do that with preamps where you can cal out the loss of the cables. Now there's not a lot of loss, but it would change this response a little bit. But at this point I don't really care about the cables because this thing is darn near perfect. If you wanted to see what it looks like further out, you could go ahead and right click on that. Let's see what it looks like out at 50 kilohertz. And you can see it starts dropping off a lot here. So this would be 20, 30, 40 kilohertz. So it's still not down half a dB at 40 kilohertz. Now some of this drop off here is due to, I believe, the FFT. If I increase the FFT a little bit, let's see if it cleans that up. Not so much. So it may just start having a higher roll off at that point. Now if I wanted to know what that value was, I could actually come over and hit the cursors. So let me hit cursor 1, and it usually warns you about the FFT. I don't really worry about that. And so you have a cursor, and you can tell whether you want that to be on the right or left channel. Let's just keep it on the left channel, and you can slide it around. And so it kind of tells you down here what the X value is. So at 15672.94 hertz, we are down 0.06 dB from that point. So if I keep on coming down, so at 41 kilohertz we're down, or 40.464 kilohertz we're down 0.3 of a dB. So you can use that to do different things. You could also just hit it to go to the center, and it would go to the center of the trace. And you could also have it go to the peak, and then if I wanted the right channel on, it'll put on a cursor for the right channel, and let me go ahead and hit that on. And you can see that the right channel now comes up, and we can move it likewise. And if you wanted to know between a delta between 2 points, you would have let's say both of these on the right, so you can see kind of what the difference is between the two. The delta X, so it'll tell you a delta X and a delta Y when you have any two cursors, but that's just one way to measure it. So that's kind of cool. So that concludes part 1 of how to measure power amplifiers using the QA40x, or at least some basic measurements of power amplifiers. If you liked the video, please click the like button, the thumbs up button, as you know. If you have questions or comments, please leave them in the space provided. And if you have not subscribed to the channel, that would be a good thing to do to help the channel grow. And let me know in the comments if you would like to see more QA40x videos. Part 2 would consist of measuring a preamplifier, which is a bit different, and some of the nuances with measuring a preamplifier. And then there may be some part 3 where I show how to do some of the automated tests and maybe some other things about power amplifier measurements that I did not go into. So anyway, once again, I thank you for checking out the video, and until next time, have a great day or night.